This is Factor Label Worksheet 5, top and bottom factor label problems. Just a little warning to begin with. This is often the worksheet where if students are going to have difficulty with factor label, this is the one. So extra attention to how we are doing this. So far we have learned what are considered simple factor label problems. So whether they were 1, 2, or 3 steps, that many fractions that you were setting up, in every problem we just changed one unit. But in this worksheet we are going to learn how to change both the top and bottom units. And if that's not clear, hopefully the example will clarify. But we're still going to use the same basic setup, where we set what we want to find equal to what we know or are given, and then we multiply by fractions, where the whole focus is the units and getting the units to cancel out. Okay, so some of you may have been to Canada before and seen that they do not measure in miles per hour like we do here, right, their speed, but instead on their highways they post the speed limit as usually around 120 kilometers per hour. Right now, to simplify this problem a little bit, I'm going to give you a conversion that is not in your conversion table. 1 mile is equal to 1.6 kilometers. So we are going to set the problem up over here the way we always do. We are going to put what we want to find first. And so in this case, what we want to find is miles per hour, right? So when we write miles per hour as a unit, we write miles and then a fraction line, which means per, and then the hours, right? So that's what we're putting over here. And we are setting it equal to the 120 kilometers per hour. So again, what we're doing here is we have a unit with a top and a bottom. The miles on the top and the hours in the bottom, the way we show speed in the US, and then the kilometers on top and hours on the bottom, the way they show the speed limit in Canada. So, at first this might seem complicated because you have all these different units floating around. But when you compare over here what we are starting with, and then over here what we are trying to end with, you'll notice that what they have in common is they both have hours in the denominator, in the bottom part of the fraction. And so because of that, we can just let hours kind of hang out there. We don't really have to worry about them. But in the top of our fraction, we start off in kilometers and we end in miles. So that's what we really need to work on changing. So if I set up my fraction, right, so I got my little picket fence going on here. If my focus is to cancel out kilometers, then I'm going to use this conversion factor here, and I'm going to put the 1.6 kilometers in the bottom, right, and the 1 mile on the top, which allows me to cancel out my kilometers. And now I can see that the only units that I have remaining are the miles on top and the hours on the bottom, which is what I wanted. So now I am ready to do my calculation. So I do 120 divided by 1.6, and that's how I get my answer of 75 miles per hour. So, the first 2 problems that you're going to be doing should be relatively straightforward if you follow that example. But I want to highlight 2 problems that are just going to look like slight variations. So let's take a look at problem 3. So you want to have out a separate sheet of paper to do this on. I'm going to do it down here at the bottom of the slide. And you can just go ahead and label it worksheet 5 and then problem number 3. And you'll go back and do 1 and 2 later in class. Alright, So problem 3, we're going to set this up the way we always do. They're giving us a big hint. They're telling us we're trying to find meters per minute. So remember, per is the line. Meters per minute, and I'm setting that equal to what I have been given, which is my 300 million meters per second, or the speed of light. And you might choose, when you're working with this, to put it in scientific notation. That might make life a little bit easier. Okay, so if I compare what I'm starting with and what I'm ending with, what I notice is that my my meters in the top and the numerator do not change. So I'm just going to kind of ignore those for now. Just let them hang out there. And what I'm going to focus on is changing the units in the denominator in the bottom of my fraction, because I need to go from seconds to minutes. So if I set this up so that I have a little picket fence, right? I know, or I can look up in my conversion chart, that there are 60 seconds in 1 minute, which allows me to cancel out the seconds. And you got to be really careful when you set this up to set it up in the right direction. Keep in mind that the unit you're trying to cancel out, the seconds, is down in the bottom of your fraction. So you got to make sure you got the 60 seconds up in the top when you set up your fraction. And that actually is going to do it for me, right? Because now I've got meters still up in the top. Didn't have to do anything for that. And then minutes in the bottom. So I'm actually ready to solve. So if I do my multiplication correctly across the top, what I get in scientific notation, so I have space to write it, is 1.8 times 10 to the 10th meters per minute. So that would be my final answer. Alright, so make sure you've got that all written out, and then I am going to erase this, and we're going to do one more together. Okay, this next one, we're going to do problem 4 together, and this is the one that sometimes stumps the best of them. Alright, so make a little space on your paper for number 4. We're back to talking about speed limits in Canada. So what we are trying to solve for is centimeters per second. And we are going to set that equal to what we are given, which in this case is 90 kilometers per hour. So on these top and bottom units, again, you always want to compare what you're starting with to what you're ending with. And here, unlike the previous two problems, we're actually changing both the numerator, it needs to go from kilometers to centimeters, and the denominator, it needs to go from hours to seconds. So you really could start with either the top or the bottom, but you need to do one at a time. Because what a lot of you are going to do on problems like this is you're going to search your conversion table trying to find a conversion that says how many kilometers per hour are equal to centimeters per second. And that's not going to happen. You don't have any top and bottom units in your conversion table. So the trick to these problems is to think of them in two parts. So I usually start with the units that are on the top. So my first goal is going to be to convert kilometers to centimeters. And I'm just going to kind of ignore the hours and seconds right now, even though I know I'm going to have to come back to them later. So, if I just focus on my kilometers to centimeters, right, I know that in 1 kilometer there are 1,000 meters, and in 1 meter there are 100 centimeters. So that was already a two-step conversion right there. But that allows me to cancel out kilometers and meters, and it gets my top units as centimeters, which is good because that's what I want. But I'm not quite ready to solve, because if I solved right now, my answer would be in kilometers per hour. So now I have to go back and think about the units that are in the bottom of my fraction. So I am currently in hours. I want to get to seconds. So I know, or I can look up, that in 1 hour there are 60 minutes. And notice that I was careful to put hours on the top of my fraction here, because the hours I'm trying to cancel out is over here in the bottom. So I know the hours are far apart from each other, but same principle applies. As long as one is in the top and one is in the bottom, they cancel each other out. Alright, that doesn't get me quite there. I still need to go from minutes to seconds. So I know that in 1 minute, there are 60 seconds. Cancel my minutes out, and now I'm finally ready to solve, because I have centimeters in the top and seconds on the bottom. Right? So this is going to be a lot of multiplication and division here, but just stick with it. You've got 90 times 1,000 times 100 divided by 60, and then divided again by 60. So if you do all of that, you should get 2.5 times 10 to the third, or 2,500 if you're not in scientific notation, centimeters per second. And that will be my final answer. So that's probably the most challenging type of factor label problem that you would get on your upcoming quiz. When you get to class next, you are going to finish the remaining problems 1 through 6 that we have not done, and then if you'd like, you can go on to the extra challenges, which are more story problem based. But the really good news to end on here is that I have now presented all of the new information in the factor label packet, and the rest is review.